Good morning and welcome to our May Tech Talk from the Reynolds Company. You just heard that we are recording this session, and we do make it available afterwards on our YouTube channel. My name is Wayne Welk, Automation Specialist with the Reynolds Company of New Orleans, and I'm just going to simply introduce our topic and our guest speakers today. We're very fortunate to have Panduit join us. And our topic is going to be on cable cleats for short circuit protection. So joining us today are Adam Hong, Andy Booth, as well as Rob Reel. I'll let you guys take it from here.
Okay, thank you.
Appreciate it, Wayne.
Yeah, absolutely. Should I go first with the introductions, guys?
Yep, go for it.
Okay, so my name is Andy Booth. I head up the Cable Cleat business unit. I'm based out of the UK, but travel into headquarters maybe twice a quarter, quite often. My background by trade, I'm an engineer. I'm a chartered engineer and draftsman. But for the last 26 years, I've been involved in the design, the testing, the manufacture, the production, and the selling of cable cleats for short circuit protection. Like I say, I'm a chartered engineer over here in the UK. I'm a member, I'm a fellow of the IET, which is our Institute of Engineering, and I'm a senior member of the IEEE. And now I head up the business to do with cable cleats together with Adam Hong. And we have a guy over here in EMEA who is a kind of shared resource between us and the rest of the European community, Chris Bentley. He's a qualified design engineer. So if you guys have a problem or an opportunity, we can turn it into a solution pretty quickly. But that's my background, specializing in cable cleats for 25 years. Over to you, Adam.
Appreciate it, Andy. So just as a brief background for myself and to everyone here in the audience, I am the product manager here for the Cleat business, and I work under Andy Booth. Andy Booth, as he's mentioned and as he talked to you, we consider him the cable cleat guru just due to his vast experience both on the product side, the solution side, and even operations side of things. For me personally, I am an engineer by background. I'm an aerospace engineer that used to be in the drone industry, and I've always had passion for business. So eventually I started stepping into more of a business role. And in all honesty, I don't do as much aerospace engineering anymore. However, it's a now no regret situation because I do get to still work on technical items such as cable cleats, but I also at the same time get to expand my own personal portfolio where I get to work on business related items as well. So that's kind of just a brief representation of who I am. I'm hoping that everyone on this call is going to have a good receiving of the presentation, what a cable cleat is, as well as potentially further discussions in the future. What I would like to do here is just do a little bit of housekeeping. So I personally will be presenting, and if you would have any questions, feel free to drop them in the chat. Andy Booth is going to help me field some of those questions in the chat so that we can do two things at once. And then if we finish the presentation early, we can have a formalized verbal Q&A session as well. So first and foremost, sorry, just let me double check. Rob, Wayne, is my presentation still showing? My screen just went blank for a second.
Yep, you're good.
Correct. Yes.
Oh, perfect. Okay. So let's get started with the presentation because I do want to make sure we're being due diligent on the time. And what I'm going to do is I'm going to turn off my camera. I just really want to turn it on so that everyone can put a name to a face, and that if I ever meet you in person, that we can be more personable behind that. But I will pause my video, and we can get started. All right. So today, what I really want to do with everyone here on the cable cleat presentation is a high-level overview. So when I say high-level overview, we'll talk about the cleat business in terms of what a cable cleat is, some of the testing and the standards that go behind a cable cleat, the products themselves, and then how we help to specify cable cleats, and then any additional resources that we've generated and created within Panduit to help both yourselves and your customers as well. So first and foremost, As you can see, this is our title slide. In the title slide, you can see a few of our different cleats on the right. In our cleat offering, we tend to have a very vast offering to allow you to have a solution for every type of application and every type of customer you have in the field, right? We have our traditional clamp styles, which is going to be the top two, for example, and then we also have a strapping style, which is one of the ones that you see on the right side here, right? So what I'm going to do now is just continue on with the presentation. And first and foremost, what is a cable cleat? So a cable cleat is governed by a standard known as IEC 61914. This is a global standard that originally started as a British standard back in roughly 2003. It's the formalized standard for cable cleats. So when I say formalized standard, it means it governs the guidelines of how you design a cable cleat. It governs how you do the testing behind the cable cleat, how you pass and fail those tests, as well as down to, potentially even the product markings of the cleat itself. IEC 61914 is actually on its third revision. So when it started as a British standard in 2003, it eventually moved over to the formal IEC standard in 2009. And then we had a revision in 2015 and then another revision in 2021. The biggest change in this standard came from 2009 to 2015. That was primarily because the standard bodies and the committee itself realized manufacturers were finding of small loopholes. When I say small loopholes, I mean manufacturers were starting to test larger cables that had stiffer bodies, and essentially that would yield better results for their cable cleats. So when 2015 came around as a revision, what they did was standardize all the test guidelines. So they actually standardized the cable diameters that you can utilize during the test to make sure there was a level playing ground for everyone. In this standard, the definition of a cable cleat is as simple as a fixation device that bundles around a bundle of cables and is mounted onto a fixing structure such as a cable tray. This fixation device is spread across different intervals along the actual cable length that is calculated, and the eventual purpose of this product itself is to protect you against a short circuit event. Along with the cable cleat, we have another product that is known as an intermediate restraint. The intermediate restraint is simply the same thing as a cable cleat, so it's still maintaining that bundle, but it now doesn't have to be fixated to the tray itself. So its primary purpose throughout the whole short circuit event or protection system is to make sure that the bundles stays within its current formation and to make sure that the cables do not flow out and to create that cable whipping. We talked about the IEC 61914 and what it governs and the guidelines it provides to testing. I wanted to kind of just show you guys a quick synopsis of some of the things that the actual standard itself does cover. So for example, it goes through a lot of rigorous testing, so we need to make sure that it can fulfill minimum and maximum application temperatures. It has to go through impact resistance, lateral and axial load, which is extremely important when we think about running cables in a vertical application. Corrosion and UV resistance, purely due to the different environments we exhibit these cable cleats to in the field. Resistance to flame propagation, as well as the product markings and documentation. On the right, you can see some of the internal images of how we've done our lateral axial load testing. We actually have in-house Instrum machines that create the tension load for us to figure out, what the max load of the cable what the max load you can exhibit on the cable cleat before any of the cables begin moving and sliding out of the cleat itself. The main thing that we want to mention, though, is in IEC 61914, the most important requirement that it portrays is the resistance to electromechanical forces. So in an electrical system, when you're pushing current through there, if the resistance drops, that current eventually increases. When the current increases, it hits its peak current point, and during its peak current point, that actually translates directly to electromechanical force that the cables themselves exhibit. So I'll show you a few videos and some slides down the road, but essentially, during those short circuit events, they do relate to a electromechanical force, which is what cable whipping comes from. And for us in the IEC standard, What we have to do is test all of our products to one short circuit test and two short circuit tests, and both of them have to pass, where pass is as simple as making sure it gets hit with a short circuit and there's absolutely no insulation damage. Once we get hit with those short circuit events, to further confirm that there is absolutely no insulation damage, even down to the microscopic level, we do something called a voltage withstand test. The voltage withstand test is a test simply where we water down the entire test setup, and then we apply AC or DC power through the cables, and they have to hold that voltage for roughly 1 minute. And that would prove whether or not the insulation has been nicked, damaged, or it could lead to a further short circuit event itself. Here in North America, I know we really like our NEC code book. I call it the Electrical Contractor's Holy Bible. Everyone uses it to pretty much understand all the regulations and guidelines on how you install product, as well as how do you protect the customer towards any type of catastrophic events. Today, the IEC code book does have some definitions regarding what you need to do against magnetic forces or short circuit events. However, if you read any of the statements that are on the screen, the problem with it is it doesn't go in detail. So at this current moment, the NEC code book tells you that you need to bind or bound those cables down to a structure, but it doesn't tell you what type of product to use, how do you calculate the spacing between the product, or go into the specific details that the IEC 61914 code does today. So our goal in Panduit is one, where we are a product company, we're an engineering company, and so outside of products themselves, we like to try to do things such as thought leadership. And when I say thought leadership, it's simply we like to make sure that your customers and yourselves are protected no matter what. So that means going into all the individual standards bodies and making sure those standards bodies are aware of the effects of a short circuit event, are aware of the global standard, which is IEC 61914, and potentially creating a new standard that's regionalized for North America within all the common standard bodies. So the common standard bodies could be UL, NEMA, CSA, IEEE, you name it. We're trying to work with all those different bodies to create a centralized standard that is based on the IEC, but also catered towards our market here in North America. In terms of the National Electrical Code, generally what happens is the National Electrical Code gets updated on a 3-year basis. And so we've already missed the timeline to update the 2023 code book. So we're in the process of trying to update and educate on the 2026 code book. So the earliest that it would become part of this NEC code book would be in 2026. However, we are doing a lot of legwork before that with a few different standard bodies to get that education rolling and to get that exposure rolling as well. I want to show you guys really quick on a few examples of what a cable cleat and intermediate restraint looks like. First and foremost on the left, these are Panduit specific cable cleats. So we have a mix of intermediate restraints and cable cleats. You can see that similar to when I talked about in the title slide, you have your clamp style, which is going to be your top right and your bottom two. And they are utilized for various fixing configurations. So for example, the bottom is being utilized for a single 1C cable, whereas the top is being utilized in a trefoil formation for 3 1C cables instead. We also have the strapping lineup, which also works both for those trefoils, those singles, but also for a multi-core cable. So if you're used to a lot of 3C cables, we do have options to make sure that those are securely held in place as well. And then on the right, we just want to show you outside of our own Panduit offering, what other examples exist out there that are also considered cable cleats. The one trend you're really going to see is most cable cleat manufacturers tend to have that clamp style, whereas we do have the strapping style that has its own benefits above any of the clamp styles. And I'll touch on that as well in a few slides. We get the question a lot about how these cable faults can happen in the field. And cable faults tend to happen on a daily basis. Generally, a cable fault can happen at a lower magnitude or even up at the higher magnitude. Cable faults generally happen, though, when the insulation itself is damaged and the conductors themselves are exposed to the different phases or exposed to ground. This can happen in a few different ways. It can happen through thermal degradation, electrical degradation, or what we mainly see mostly in the field is mechanical degradation or mechanical effects, both internally and externally. For mechanical effects, this can happen throughout the life cycle of the cable itself. So when I say this, it can happen even from the manufacturing process. During manufacturing, this cable could have been manufactured with a small defect that was missed. During shipment from even manufacturing to a facility or any facilities, during that shipment process, it could get damaged. It can get damaged when it's on site, it can get damaged when it's in storage, and it can get damaged when it's going through maintenance. So there's multiple ways mechanically that this cable itself can get damaged, and that eventually leads to short circuit events. So what I want to show you is just a quick example of a team that is excavating underground, and they're digging through the concrete. They're going a bit deeper. They hit something, and when they hit something, some sparks fly, smoke happens, and then eventually they realize what it is. Upon closer look, they realize during excavation they went deep enough where they actually hit power cabling, and that nicked the insulation, which eventually caused it to have a short circuit event itself. In addition to this, I wanted to show you guys another few examples of insulation damages that still happen in the field. For example, on the bottom middle, you have a traditional clamp style cleat that's going through maintenance. The cables have been lifted outside of the cleat, but they were lifted, but they were placed back down without looking. And unfortunately, due to this, the cable has been placed on top of the stud, and that stud has now protruded or has stabbed into the insulation, which actually ended up causing a short circuit down the road, creating a cable whipping effect that you'll see in future videos as well. The other ones you'll see here, for example, on the left, you can see the cable was laid on concrete or rocks, and essentially that over time started digging into the insulation, leading to short circuit failures. So the main aspect I want to portray to everyone on the audience is that these short circuit failures can happen at any moment, any time, and anything can really cause them. So our goal for cable cleats is to prevent any of the aftermath damage that could happen when this type of insulation damage does occur. So enough talking. What I want to do, and the best way to show you what actually happens during a short circuit event, is to show you a failure. So this is actually a failure for 3 1C cables. I think these are 600 volt or 1000 volt cablings, and they're wrapped in what we call a trefoil formation or triplex formation. And we are actually testing one of our products, but we are testing it beyond its capabilities to understand, one, what the maximum capabilities of the product itself is, but two, to understand just generalize what does happen during a short circuit event. So I'm going to play this. And Wayne and Rob, if this is not playing correctly, just let me know.
No, it's showing well.
Perfect.
Yep, it's good.
So as you can see in the video itself, this is all happening in milliseconds. And when I say milliseconds, it's happening very, very instant. And what's occurring is during that short circuit event, all that current's being pushed through, and that current is now relating to electromechanical force, as we mentioned earlier. That electromechanical force has caused the cables to repel from each other, ultimately destroying the cleat or destroying the fixation device that's on there, but also destroying the cable tray. And imagine if you had actual personnel standing by that, they could be hit by this cable and you could have a potentially fatal injury. And then the other thing you could think about is if this was connected to a major piece of equipment, such as a transformer, potentially this would have damaged your transformer as well. The only reason why the damage doesn't occur beyond the middle section here is because during our testing, we over-engineered 2 end conditioning clamps that you can see at the ends. And that is purely to keep it in place so that we don't damage the lab itself during testing. I want to show you another video because simply in North America, we use a lot of tray cables. So tray cables, we have a lot of conductors in there. And the perception behind tray cables is that if it's an armored cable, you're already protected against a short circuit. That perception is false because the armored cable, it protects the cabling and the power conductors inside from any of the outside forces or outside elements, but it doesn't actually protect against the true forces that cables could exhibit during a short circuit event inside. So I'm going to play this video, and you're going to see what happens to a multiple cable. Hopefully the video is going through full effect here during the presentation, but what you can see is the 3 conductors inside the cable have done that same repelling effect, and it has eventually repelled at a fast enough speed where it's turned all the jacketing into shrapnel. So again, imagine this next to large equipment. Imagine this next to people. Imagine the amount of downtime and the amount of work that needs to be done to go back and fix something like this. One thing I do want to mention in this video is that there was a spark that happened. There is a fire that is happening. And I will tell you now that cable cleats is not a device that is going to stop a fire from happening. It is a device that is going to mitigate the cable whipping, which in turn does mitigate a potential fire from occurring, because the sparks and the fires are simply when the cables have whipped and they started degrading their own insulation, coming into contact, and eventually creating these sparks. So why are they necessary? So without going into too much detail, we have a current over time curve on the left. This is across, I think it was 8 phases on an asymmetric RMS curve. Your peak current is really going to happen near your first phase, as you can see on the left side. Your peak current is happening roughly 5-4 milliseconds within the system. And when that occurs, a lot of people tend to ask, well, okay, so if I design it correctly and have a circuit breaker or circuit tripper, it should protect us from this, right? The answer is both a yes and a no. And the reason I say this is because a circuit breaker tends to trip at 0.0 second or 0.06 seconds to 0.1 seconds. That is roughly midway through this entire phase graph. And it does shut off the system to protect it from further damage. But any damage that's occurred during the highest peak current has already occurred. So it does shut off the system, but unfortunately, any damage that existed during that short circuit event has already existed. And what we want to state here firmly is that cable cleats, because you install it the moment you do the cable runs, it's already protecting you from the moment it's installed to the short circuit event and even after the short circuit event, right? Because it's already a fixation device, you're not waiting for a signal to send over to, let's say, a circuit breaker for it to trip. It's already there, making sure your bundle is retained. The other thing I want to mention here is when we do calculations and when we understand electromechanical forces, voltage is irrelevant in this entire case. So we have actually seen situations where you would use a cable cleat for low voltage cable, medium voltage cable, and in some cases, even high voltage cable. So it's always important to make sure that you're cleaning your product no matter what, because the current that's running through that is what's mainly related to that electromechanical force at the end of the day. One of the cool things that we do here at Panduit, and one of the things that we do that no other manufacturer does, is that we designed a simulation software. So we utilize a world-renowned software called ANSYS, but we had engineers within our Panduit facility design all the actual programming and the parameters that go into ANSYS to simulate what happens during a short circuit event. So we've taken into account things such as the cable type, the cable cleat itself, the cable tray, even the fasteners on the cleat and the fasteners that go on the tray. And it's taken into all those different parameters, and it's predicted how the cables and the overall fixings would react during a short circuit event. This is very crucial for us because, one, when we do this during the design phase, it allows us to go back, redesign or redefine our cable cleat and build it to be the best it can be before we take it into a real-world testing situation. So what I want to show you here is a video of what you would see in our simulation, and then how our simulation accurately predicted what would actually happen in the field when we did short circuit testing. So as you can see, the simulation itself has shown 3 phases, continuing to repel, continuing to jiggle a little bit within the cable cleat, and eventually when that peak force occurs, the cable cleat is destroyed, and the cables have flailed everywhere. So it's literally, for us, we use simulation as an initial understanding of the situation itself and what could happen. And then we do the testing because one, the standard itself requires testing to be certified. But two, we use the testing to also verify our findings of what we originally thought would happen during simulation. What I want to show you here is also what happens when you, one, properly specify a cable cleat, but two, when that cable cleat is specified correctly and it's doing its job, what potentially could happen to the cables itself. Again, this is happening all in milliseconds. This is for 1C cabling and triplex or trefoil formation. And during the actual short circuit event, you can see that the actual event is still pretty violent. It shakes everything, even the camera that's on its tripod. And essentially, all that's happening within the cable is it's jiggling within the cable cleats. But at the end of the day, it's still retained to the cable tray itself. The bundle is still retained in somewhat of its formation, and there's no extraneous damage that is occurring to your immediate environment, your immediate personnel, or potentially even any of the major equipment these cables are connected to. I'm going to show you another example. So the previous video showed one of our MS strapping cleats and how it performs under short circuit when it's specified correctly. This is actually one of our traditional clamp style cleats. We call it the CCSSTR. We also call it the stainless steel trefoil, but you're going to see the effects are roughly the same as well. During a short circuit event, you still have the cables moving rapidly within the cable cleat, but the cable cleats continue to keep it retained to the overall system, preventing any of that damage. I will mention here that sometimes we get the question when we show these videos, do you have to cleat every rung just like these videos that we're showing here? And the answer is no. In our short circuit testing, we have to cleat at 300 millimeters or roughly 1 foot spacing. And we also have to cleat at 600 millimeters, which is roughly 2 foot spacing. That is based on the testing parameters itself. That's what we have to do. However, for an actual customer application, we could specify further spacing, but it all comes down to the short circuit calculations, the cable cleat we're going to use, and then ultimately the rung spacing of the actual cable tray itself. Cable cleat has a lot of applicable markets. So you can use cable cleats pretty much in every market that uses AC power. We have had opportunities that customers would like to use this on DC power. So we have done DC power calculations and specified cable cleats as well. So generally, if you're running a cable, you're running power cable through cable tray or any fixation device, there's an application for cable cleats. So what I want to do here on this slide is just to simply show you the vast opportunities there are for a cable cleat to be installed in a real world market. So for example, you can install this in oil and gas. You can install this on, you can install this in the refineries. You can install this on drill ships. You can do petrochemical. We've had quite a few opportunities within the petrochemical field as well. Power generations, that could be things such as nuclear plants. Big one for us is data centers. So if you guys do a lot of business in data centers, especially in this growing market, we do protect on the data center side. Rails, so if you're thinking of railroad or metro tunnels, we also do those as well. We're starting to get into alternative energy. So you can imagine cable cleats being placed all the way up the vertical sections of a turbine, even at the top of a turbine. But at the same time, we're also doing things such as cable cleats on solar applications as well. And then just to finish off, just to kind of complete list of all the different markets you can see we really have had success in. So the main aspect I want to portray to the team and everyone on the call is that, again, if there is a time where you're running power cables for an extended period or extended length, there is an application for you to install cable cleats, both as a fixation device, but also a potential protection against a short circuit event. So with that, I'm going to walk into the actual products themselves. I won't get into too much detail because we do have a lot of SKUs, but I'm going to be a little bit high level and talk about some of the potential benefits between each of these SKUs. One thing I want you guys all to remember though, and then I want this to ingrain into your brains, is that Panduit's cable cleat offering has two functions. First and foremost, it's a cable bundling device, but the most important function behind it is it also offers short circuit protection, right? So all those videos we showed you beforehand where the cables are whipping and the catastrophic events are occurring, it protects you against those and offers during that protection, it also mitigates any downtime you have at facilities, as well as any time that you need to do analysis to figure out where that short circuit came from. Our main selling cleats here globally, we have two types. First and foremost is our strapping version cleats. We have them in two variations. We have what we call the MS buckle strap, which is going to be the one in the left picture. And we also have our MLT locking strap cleats, which is going to be in the right picture. These come in two flavors of material. We have in 304 stainless steel and 316 stainless steel. The best benefit about these products is one, they're Panduit specific. So we're the only manufacturer that does strapping cleats. But besides that, they are suitable for a wide range of different applications. So you can use them on single cable or multi-core cable. You can use this in those trefoil or triplex layouts. Those quad layouts or quadplex layouts, and even custom cable layouts. So if you have a customer that says, hey, look, I want to bundle 5-6 cables together, is that possible? We help you do the calculations to understand if that is possible and then which product within the strapping lineup would be suitable. So we have done many times where custom layouts are definitely possible, but what you'll see traditionally in the market is probably going to be more of the trefoil and the quad setup, where trefoil will be your 3 phases bundled together. The quad could be your 3 phases plus the ground bundled together. The other thing that these cleats do very well is because they are a strapping setup, they have huge range taking capabilities. So I say this, if you're trying to decrease your bill of materials, you can have one part number that can fulfill the entire project simply because that one part number can fulfill multiple cable diameter ranges. As a perfect example, one of our sizes lets you encompass 12 millimeter cable all the way up to, I think it was 60 or 70 millimeter cable, right? So having one part number being able to do all that, but also being able to wrap around the different configurations and form to shape gives it that additional benefit above any other traditional cleat. The other thing it does well is because it has because some of these have power tools, namely the MLT version, you have increased productivity because you can install these very fast. It tensions right away and it cuts right away. And the other thing we also want to make sure is that we know that every manufacturer, every distributor, every end user is going to have a different type of cable tray. So we try to make sure that all the common cable trays in the market have a mounting solution that allows our cable cleats to install on there. And then the last thing that I want to mention here is also these MS and MLTs, strapping cleats. They can potentially provide huge cost savings versus any other cleat that's out in the market. And we can do that through the quantities by spacing them out further, but we can also do that simply because of the material cost itself. So these are the products that we tend to specify into many, many opportunities in different various markets. But at the same time, we do have customers where they want the traditional clamp style trefoil cleats, right? These cleats are going to be very form fixed. So, one lineup is only going to be able to work with trefoil layouts. One lineup is only going to work with quad layouts. And then we have multiple SKUs that encompass all the common cable diameters in the market today. And the one benefit that's different between the actual strapping versus the clamp style cleats is the strapping, you do tend to have the cables pulled, then you can install it because it needs something to bundle over. Whereas the stainless steel trefoil and the quad, you can actually install it before the cables are pulled or after the cables are pulled. So depending on your customer setup, some of them like to prefab, so they may prefab and have the cable trays have all the fixings already on there, and they can use this cleat to put that on there as well. And then they'll pull the cables through. Traditional methods would be pulling the cables and then installing something after. So we're giving you guys options on how you can install cable cleats. Similar to the MLT and MS, we've designed different types of mounting brackets to allow you to install that cleat specifically on all the different cable trays. So if you work with, for example, B-line I-beams, whether it's aluminum or steel, we have a bracket for that. If you work with MP Husky top hats, we have a bracket for that as well. If you work with any of the Hubbles or any of the other cable tray manufacturers out there, we have most likely designed a bracket to allow our cleats to be installed out there. If we haven't, for some reason, we have done some custom designs and custom engineering to create a bracket so that they can be installed. In addition to those two types of selling cleats, we do have offerings in aluminum and polymer. Our goal behind these cleats is to, one, give you options in material, two, to make sure that we fill a overall portfolio against any competitors come into play, but then three, also pretty much provide you another piece of, another option depending on your short circuit. We still have them for Trefoil layouts and then single and multi-core layouts. For the 2-hole, which is the center images on the top 2 rows, and then the right images is going to be your 1-hole. The nice thing about these cleats is you can also stack them into a matrix format. So if you didn't want to use a strapping lineup, or your customer tells you, hey, I want my cables to be in a 3x3 matrix, we do allow these cleats to be stacked so that you can set up a 3x3 matrix. For these type of cleats, however, we tend to limit the amount of tiers and stacking up to 3. And it's purely because it's not because the cable cleats themselves can't handle it. It's because the stud and the hardware, as you continue going higher and higher, that now becomes the issue rather than the cleat itself. So we try to limit it at 3 just to protect ourselves, but also protect your customer from any potential variables that you're now introducing. And the last thing in our portfolio is all the accessories. So I mentioned already all the brackets that we have that allow you to install them to all the different cable trays in the market. We also have those innovative power tools, both in the hand tool crank versions and also a power tool version to allow you to install our MS straps and MLT straps. And we also have various cushion sleeving. So we have 2 types of cushion sleeving. We have one that's a reel. It comes in 100 feet, and you literally cut it to length and wrap it around the bundle itself. But we also have an innovative and intuitive cushion sleeving that's already cut to a specific length for specific cable diameters. And all you do is wrap it, and it installs similar to an actual cable tie. So it holds itself in place. But at the same time, we've had customers who use it to dress the cables to keep them into their trefoil or quad formations before they install an actual cleat on there. So I'm hoping I'm doing good on time. I want to just briefly talk about how you specify cable cleats. So generally, when we specify cable cleats, we within Panduit do all the calculations. We give you guidances on how far to do the cleat spacing, what product works best, but at the same time, taking into account all the important variables from you, right? So if you are focusing on TCO, we make sure that's top of mind for us as we're proposing for you. What we really need from you is to help us get some of these variables to do some of the initial calculations. So anything that I'm going to present out here that's highlighted in yellow, those are the absolute minimums for us to get started. Anything else beyond that is just going to be additional because it helps us specify the best cleat possible. So first and foremost is we need your peak fault current for the system. Sometimes if you don't have that, we tend to have our RMS current already. And if we don't have that, we can take a look at the worst case, which is going to be your breaker or circuit tripper ratings. A lot of times this information is going to be obtained by the electrical engineers or the electrical firm that designed the overall system and how the cable runs are being connected from point A to point B. We also like to know the cables themselves. So when I say cables themselves, cable types. Is it a 1C cable, 3C cable? What type of material is it? You name that kind of portion, and we try to take that into account. The important aspect behind it is also we need to know the cable outer diameters. That affects both the sizing of the cleat itself and also the calculations, because the calculation is going to be based off of the center to center conductor spacing. Last thing that's good to know is the bundle formation. So depending on the project, is it going to be wrapped in a triplex? Is it going to be run in parallel flat formation where all 3 phases are just spread out across the cable tray? Is it a 3C cable? Is it going to be a quad formation? You name it. So we want to know that information so that we can firmly specify the correct cleat. Other things we want to know is the cable tray. So the cable tray is important because it simply tells us, one, what type of fixing method we need to utilize to attach our cleats to that cable tray. But two, it tells us the cleat, the rung spacing, so that we can use that as our increments of cleat spacing when we give you our proposal. And then we also take into consideration any of your environmental and application parameters. So are you installing this indoor, outdoor, corrosive environments? Is it going underground? Is it going overhead? And as well as, are you going to be installing all the cables just purely horizontal, or are there going to be bends and risers going vertical as well? Once you have as much of this information as possible, or at least the highlighted information, we ask that you consult ourselves as a Panduit team, or you consult our team at SMR Gulf Coast, such as Rob, and we will help you create a proposal at the end of the day. So when you do have that information, you provide that to us, we calculate your short circuit forces. We calculate your short circuit forces through different intervals, such as 1 foot, 2 foot, 3 foot, up to 4 feet spacing. We tend to stop at 4 feet spacing purely because any further than that, you're going to reintroduce cable whipping. If you do have an application where you say, I absolutely need 4 feet spacing, we take a look at that specific application and we may propose what we call the intermediate cleat, at least hold the center of that bundle in place and to mitigate any of that cable whipping effect from coming back. When we do those calculations, we also try to take into consideration all your requirements. So if you're focusing on TCO, labor time, you got vertical and horizontal installations, what type of cable tray you're using, is it indoor, outdoor? We take into account all those things. And then we try to propose somewhere between 1 to 3 solutions. The reason why we propose 1 to 3 solutions is to provide you options. It's to provide you the option that you can use this one for faster installation time, you can use this one because it's a bit cheaper, or simply you can use this one because this is the one we have in stock at the moment, right? So we want to make sure that we propose you different options so that you can make a firm decision based off of what you need today and what the project itself requires. And then after those options have been selected, we tend to look at if we need to add accessories. So if the cable tray is very specific, we may need to add a mounting bracket. If it's a strapping cleat, we may need to add cushion sleeve and installation tool. So we'll add those accessories after we figure out which type of product you like the most. And then at the end of the day, sometimes we have customers that ask for a bit more documentation so that there's some traceability in the actual specification of the cleat. So we have written some soft and hard specifications for end users. We've helped write letters addressing different questions. We submit published lab reports showing our tensile loop results as well as any of our test results. We send videos, spec sheets, you name it. Whatever resource you and your customer may require, we can definitely generate those and make sure that you have it on file so you can trace back to what was installed, how it was installed, and what entailed in the overall application. So I want to touch really quick on a high level of once we use that information, how we do the formal calculations. This is the formula that's been given by the IEC 61914 standard. It is 0.17 times your peak current squared over the spacing of your conductors. In the case of a trefoil or any of the formats where the cables are being lumped together, your spacing simply becomes your cable diameter because that's your center to center spacing. When we have this, an example would be to have an input of 75.1 as your peak current and your spacing being 38 millimeter cable. We take that, plug it into this formula, and eventually we get a force. This is the overall short circuit force for that application, but to get down to the detail of how we specify an actual cable cleat itself, we need to take this force and we need to multiply it by its spacing. I apologize, we're working in millimeters, it's all metric. I know we tend to use imperial here, so bear with me. But the traditional spacing that we tend to multiply by is either 300, 600, 900, or 1200 millimeters. In North America, it would be 1 foot, 2 foot, 3 foot, 4 foot. Or if it's down to the actual rung, it could be increments of 9 inches, increments of 6 inches, and increments of 12 inches. When we multiply that, the perfect example down here shows the value if we were to try to aim for 300 millimeter spacing. When you plug in that calculation, you get roughly 7.5 kilonewtons of force. And that is the force that we need the cleat to resist. So we take this force and we compare it to all of our cable cleat mechanical strengths. And that's how we determine which cable cleat suits the need of this application. And then after that, we also take into consideration all the different application and environmental parameters, such as vertical and horizontal installations, what type of cable tray, inside, outside installation, and then all use those to finalize the firm proposal at the end of the day. One thing that we've tried to do is also try to design a Cleat calculator. We're the first manufacturer to have a Cleat calculator. We have a desktop version at the moment, and it uses those main parameters I mentioned earlier. All we need from your customer is the cable layout. So whether it's a trefoil, flat, multi-core formation. At the current moment, we don't have a setup for quad formation, but if you're purely doing a calculation, you can definitely use the trefoil version to do a quad calculation. When you have that, we also want the cable diameters because that does affect the spacing between conductors. And then lastly, the peak current event. When we have all three of those parameters, it's going to spit out a output. And within the output, it's going to give you the same details we would provide to you when we do it longhand style from Panduit ourselves. So it's going to give you multiple proposals of which products to use, where it should be spaced, as well as other technical information such as the maximum amount of current it can resist at those specified spacings. And I know I'm running tight on time, so we have a few slides left to finish up, but I want to show you guys something that we're trying to identify here in the market. We know that contractors and installers, one, they can be in loud situations, but two, they have very little time to watch 5-minute videos. So if they need to understand how to install a product, our goal was to create a quick, down to the point installation video that is animated so that you don't have any of the distractions such as a person or hands fidgeting within the video. The goal here is to simply provide you a straight to the point video of how you install the cable. These videos are roughly less than 1 minute, and they tend to have on-screen text so that if the installer is in a loud environment, they can read the text, but also see firsthand on a video basis how you firmly install this. So right now, this is showing one of our MS cleats, and we have this also for the MLT strap cleat. And then we're in the process of also updating all of our other clamp style cleats that have a similar installation feel so that no matter which product you use in the field, the installer is going to have a quick video to reference to learn how to do the job. Here at Panduit, we also like to create a lot of resources. So our goal was to create as many resources as possible to educate the public about cable cleats, why you need them, what products we offer, how you do the calculations, why you need to use them instead of cable ties. So we try to create a lot of these resources, both in short form and also in long form, which is what we call white papers, so that you can have something to show or something for you to read yourself. The main aspects here, we have a landing page. We have 3 landing pages with all these resources. We have those white papers. So if you want more detail beyond this presentation, we have a white paper written that tells you everything about short circuit protection, cable cleats, how we do the testing, and some of the best guidances or best installation practices are. We have all those cable cleat installation videos that similar to what I just showed you. We have product brochures, that Cleat calculator, individual data sheets for each product. And then at the end of the day, we have a lot of other other resources that give you further information about our products, the solutions, and the actual cable cleat market itself. Lastly, I want to finish off with the links to those 2 landing pages, but also a contact email. So this contact email on the top right or middle right here, which is cleat@panduit.com, that is a blanket email where if you email that, it goes straight to us in the Cleat team here at Panduit. So we are able to help you address any technical questions or quick questions or resource needs immediately when you email this, but you are also welcome to email myself or Andy Booth directly if you have any questions as well. We're more than happy to help you out virtually. We're more than happy to sit down with you physically and kind of get everything done. So whatever support you need from us, we're happy to be there for you. So with that, I hope I was okay on time. That was the formal presentation at the moment. I can give a more detailed one in the future for anyone that's fully interested, but I want to turn it back to Wayne and Rob to give any closing comments or to answer any questions.
Wow, more detail. That was an incredible amount of detail right there. Like a master class in short circuit protection for cables. So yeah, so a little bit longer than we normally do, which is great. Again, this was a great topic. So we invite anyone out there with a question, please put in the chat or raise your hand. We can ask it live. So far, it's been pretty quiet.
Okay, so this was as of yesterday. We carried out some live short circuit testing. You can see we've got 3 fairly small cables here in trefoil formation. That was it before the test. I'm hoping I can bring this. Do you see that now, Adam?
Yes.
That was the cable ladder afterwards. So you can see the cable deformation. Let me pull that one. You can see where the cables have actually ended up. The cables actually jumped right off the table. That there will be a better image, I think. Do you see that image? The guy stood with the white shirt on.
Yep, we got that.
So that rig was perfectly straight. The cables were perfectly straight. The end conditions were fastened back with those high performance straps. And that was it. We didn't even hit the peak of the short circuit. So that damage there occurred before 5 milliseconds. So Adam showed that AC graph with the sine wave on it. All of that damage occurred within something like 4 milliseconds. So just to add to, and we can supply you guys with these images and videos. We'd be happy to do that if that would be helpful to you and your customers.
Oh, we love videos of things being destroyed. Yes.
Let me see if I've got the video. Yeah, this here is the video of that test. So the guy who I had capturing this tried to hold his mobile phone steady to capture the event, and you can see how much it made him jump back. So yeah, I've just downloaded these because I returned back from the test lab yesterday, guys. So I thought it might be useful just to show some other examples. But great presentation, Adam. Thank you.
No problem. Appreciate you sharing the video there. Wayne and Rob, any other further questions or comments to close up? I did see one pop in the chat, so I'm actually typing an answer to that so that we'll have a answer to the code book question as well. But in a verbal standpoint, just to quickly answer it, the NEC code book today does not have formalized codes regarding cable cleats. They do specify that you need to bundle cable to prevent potentially these short circuit events. Our goal is to approach the NEC code book committee and try to get a more specified definition within the code book itself pertaining to cleats for both single conductor cables and multi-core conductor cables. And we're hoping that that will be part of the 2026 revision. But prior to that, we are doing a lot of legwork with all the standard committees to start driving that education and actually create formalized standards. So to our knowledge, a lot of these NEC code books, they tend to follow some of the formalized standards that UL, CSA, NEMA have portrayed. And so our goal is to work with those standard bodies to make sure that they have what they need to understand cleats and create their own standards behind them. And then working those standards to force them into the XCO NEC code book to make sure that the customers and the installers are protected by the end of the day and by the end of the installation process. Does that help answer that question?
I believe it
Yeah,
does.
I just want to make sure that everyone knows. First, I want to thank this Rob. I want to thank Wayne for setting this up and organizing, Adam, Andy for leading a great discussion. And despite the fact that right now the code does not require anything, that is something coming. And I think now is a great time to get in front of your customers with this message. It's a key safety item, but soon it'll be a requirement, we hope and believe.
Okay. Well, I think we're coming to the top of the hour, and it's like we don't have any other comments or questions, so we'll perhaps we'll close out our session. Once again, really want to thank Panduit, thank Adam and Andy for presenting, Rob as well for helping out get this organized. So appreciate it. And thank you for attending as well. We appreciate your time and attention and participation.